current topic, which is the laws of indices. And the aspect of which we want to examine today is the indicial equation. By indicial equation, we mean equations involving the applications of the laws of indices. And I've selected a series of examples which we are going to deal with in this class. So, I have up to 9 questions. And the solution follows. In number 1, I have 2 raised to the power x is equal to 8. What we are doing in indicial equation is this. We can see or observe clearly that our equation, what we call the equation, always has 2 faces. The first part, which is usually identified as the left hand side, and the other side, which is usually identified with what? The right hand side. Now, the first thing we want to ensure here is to make sure that both faces, both sides, that is the left hand side as well as the right hand side, what we have there are numbers in index form. And when we observe the first question which we have here, so we can see what we have here is a number written in index form. But the number we have at the other side of the equation is 8. It is an ordinary number which is not yet a representation in index form. So the first step to solving this question means this number has to be re-expressed, or it has to be rewritten in an index form. So to express it in index form means that I will write it as 2 raised to the power 3. Or for the one who is not yet clear about how this 8 is going to be expressed in index form, so what we are going to do in that case is to have my 8 and reduce it until it becomes 1 by way of what? Dividing it. So, and you know the simplest number with which 8 can be divided is 2. 2 in 8 here gives what? 4. Then 2 in 4 gives 2. 2 in 2 finally gives 1. So with what we have here, we can see that another way of writing it, or another way of stating it, is to call it what? 2 raised to the power 3. When 2 repeats itself 3 times, you know that is when it's going to give the value of 8. So since we want both sides of this equation to contain an index number, and this is the only one not yet in an index form, so we have to convert it to an index form following what is done here. So that's going to be 2 raised to the power x is equal to 2 raised to the power 3. And the essence of doing that is that we want to cancel out, and the cancellation can occur either at the base level or at the index level. So whichever level where we have common number is where the cancellation or the division is going to take place. So we can see that the base here is equivalent to this base, so it automatically means that this one cancel this, and we are left with what? X is equal to 3, which is the required result in this case. That is solution to number 1. In number 2, what I have there is 3 raised to the power c minus 1 is equal to 81. When we observe this question very well as well, we are going to see that what I have in the left hand side here, that is my 3 raised to the power c minus 1, is in index form. But what I have in the right hand side, that is this 81, is an ordinary number but not a number in index form. So it is also very important we convert it to a number in index form. So that becomes 3 raised to the power c minus 1 is equal to, so I can have my 81 here, and know the essence of what I want to do here is I want to break this number down till it becomes what? 1. And we can see the minimum number by which this number 81 can be divided is what? 3. We know 3 in 81 here gives 27. So when I reapplied my 3 in 27 gives what? 9. 3 in 9 here gives 3, and 3 in 3 finally gives 1. So you can see that 81 is equivalent to when 3 is repeated how many times? 4 times. So 81 is going to be rewritten as what? 3 raised to the power 4. And remember, the essence of adjusting the both to index form is for us to make sure that what? either the base level or at the index level, a cancellation is applied. So when we can see that cancellation will only occur at the base level, because the base I have here is 3, base I have here is 3. So this one will cancel this. So I am now left with c minus 1 is equal to 4. So to getting my c here means I'm going to solve this linear equation. We can see this is a letter, or we can simply call the variable. This is a number, this is a number. So what will happen in this case is this number will have to cross over equation sign down to this place. So that now becomes c is equal to 4. And we can see this is a negative 1. By the time it crosses the equation sign, it changes to what? Plus 1. And c finally gives the value of what? 5. So solution to number 2 is what? 5. In number 3, what I have there is 3 multiplied by 9 raised to power 1 plus y is equal to 27 raised to power minus y. 27 raised to power minus y. Now when we observe this question as well, we can see that not every number is in index form. So the first job here is to ensure everything is written in index form, and the only number not in index form at the moment is 3. So converting it to index form is as just to call it 3 raised to power 1, then multiplied by 9 raised to power 1 plus y is equal to 27 raised to power minus y. And for me to continue here, and let me put it this way. So what we are doing here is to maintain the same base, or to maintain equal base, but we cannot do everything here is in index form. But despite the fact that they are in index form, it is also expected of whoever is solving the question to make sure that what the base are the same thing, because we want cancellation to occur, and cancellation can never occur if the base are not the same thing. So as a result, we want to adjust everything here to equal base, and the base we are going to choose this time around is the smallest or the minimum base which we are having in this equation which we are solving, and we can see the minimum base here is 3. So since the minimum base here is 3, so I adjust my 9 here. I will now treat this 9 as an ordinary number which needs to be converted back to what? To an index form, whereby its base is going to be what? 3. Ditto for the 27 here. I want to rewrite 27. I will initially assume 27 to be a whole number, or to be an ordinary number. And what I want to do here is what? To re-express it in index form, whereby it is going to have a base of what? A base of 3. So I can continue here. So this thing is now going to be written as 3 raised to power 1 multiplied by, remember, adjusting 9 to a number in index form becomes 3 raised to power 2. Then I can now say into 1 plus y is equal to, so the same thing is applicable to 27 here. You know, it is when they repeat itself 3 times that it's going to produce the value of 27. So that is going to be 3 raised to power 3. That is 27 will be written as 3 raised to power 3 into or bracket minus y. For further information on how 27 was adjusted to 3 raised to power 3, so if we apply exactly what we did here, so we'll be able to achieve that result. Now I have to operate the brackets. So to open the bracket, now this becomes 3 raised to power 1 multiplied by 3 raised to power, we know 2 times 1 here gives 2. 2 times 1 here gives 2y is equal to 3 raised to power minus 3y, when 3 is multiplied by what? A negative y. And in the left hand side, what all we want is just a single base, while in the right hand side as well we want a single base. So we can see that that is achieved already in the right hand side, because only one base is there. But in this place here, in the left hand side here, I have more than one base, so which means I have to reduce these 2 bases to 1. So reducing it to 1 means I'm going to apply multiplication rule of indices. So base here and base here is the same thing, so 1 will be chosen. You'll be choosing to represent the 2, and in that wise the multiplication sign we're having here will change its role to that of what? Addition. That is, it will be adding the two powers of the two bases which we have here. So that's going to be 1 plus 2 plus 2y. Then that is equal to 3 raised to power minus 3y. And with this we can see the base, we cancel the base which we have here. So I will now be left with 1 plus 2 plus 2y is equal to minus 3y. So solve the linear equation here means we have to collect the like term. So it can be done this way. 1 plus 2 is equal to minus 3y is what I have here. So I want my plus 2y to move over here. So once it crosses the equation sign, it changes to what? Minus 2y. So 1 plus 2 here gives 3 is equal to minus 3y minus 2y here gives minus 5y. So getting my y here means I have to divide both sides by the coefficient of y. And the coefficient of y this time around is what? Minus 5. So I'll divide this by minus 5, this by minus 5. And we can see that minus 3 over 5 is equal to y. Therefore, my y is equal to minus 3 over 5. So that is the solution to the third question. Now in number 4, what I have is my number 4. I have 0.25 raised to power x minus 1 is equal to 32. So just like we said in some of our previous class, that indices talks a lot about a number. That is, we are not interested in a decimal number. So whenever a decimal number is given, so the first thing we are going to do is to adjust it back to what? To its fractional equivalent. So adjusting 25 to a fraction becomes 25 over 100. Then everything here raised to power x minus 1 is equal to 32. Now, once there are common factors to numerator and denominator here, that has to be adjusted first before we think of applying any rule of indices. And we can see that 25 in 25 here gives 1, 25 in 100 here gives what? 4. So the result I have here can be rewritten as 1 over 4 raised to power x minus 1 is equal to 32. Now, what we follow is we want this thing to be written in index form. So I believe you all understand very well that 1 over 4 can as well be rewritten as 4 raised to power minus 1 into x minus 1, which is equal to 32. So that is 4 raised to power minus, okay, then 4 raised to power, and now I want to open this bracket here, minus 1 times x here minus x, minus 1 times minus 1 here gives plus 1 is equal to 32. But at this junction now, we can see what I have here. This first expression is in index form, while what I have here is just a number, or what we can call an ordinary number. So it's also very important we adjust this number to what? To a number in index form. So that becomes 4 raised to power minus x plus 1 is equal to, so how do we express 32 in index form? So that is by reducing it. So we start from 2 until the number becomes what? 1. 2 in 32 gives 16, 2 in 16 gives 8, 2 in 8 gives 4, 2 in 4 gives 2, and 2 in 2 gives what? 1. So we can see we have how many 2? 1, 2, 3, 4, 5. So 2 raised to power 5 is what we give 32. So this becomes 2 raised to power 5. And for us to continue with this solution, it will be necessary for my two bases to be the same thing, because we want cancellation to occur, and cancellation will only occur when the bases are the same thing. So it shows that this 4 is going to be treated as an ordinary number, so which is now going to be re-expressed in index form. And we know very well that when 4 is expressed in index form, it gives 2 raised to power 2. That is, when 2 repeats itself 2 times, that is when it's going to produce the value of 4. So this 4 here will become 2 raised to power 2 into minus x plus 1 is equal to 2 raised to power 5. And in this case now, the base will be able to cancel out. So I'm now going to be left with 2 into minus x plus 1 is equal to 5. Then the next thing is to open the bracket. So 2 times minus x here give minus 2x plus 2 times 1 here 2 is equal to 5. Now we can now see that everything now has been broken down into what? A simple linear equation. So which has to be solved following the procedure for solving simple linear equation. So solving this thing becomes minus 2x is equal to 5 minus 2, because we know very well that whenever a positive sign changes transit its position to the other side, the positive sign changes to what? A negative sign. So that becomes minus 2x is equal to what? 3. Now getting my x this time around means I will have to divide both sides by the coefficient of x. So divide both sides by what? By minus 2. So when this cancel this, x is going to be minus 3 over 2. Therefore, x here can as well be written as minus 1 whole number 1 over 2. The next is going to be question 5. And in number 5, what I have is x raised to power half is equal to 6. So dealing with this one is as simple as well. Now when we compare this one to the question which we have been solving so far, we are going to realize that in the number 1 to number 4 question, they are the type of question whose base happens to be a number. But in this case, we are having situation whereby base, one of the base or both base happens to be a letter. Now, how we approach that one is going to be a little bit different from the way we approach the one that has its base as what? As a number. So, in this situation, what we actually want to do in order to solve this equation is to ensure that this x exists without having this power. We want this x to exist without having this power again. And for it not to have the power means I must find a means or a way or rule by which this power has to be removed. And one of the things we can do is this. So let me rewrite my question. X raised to power 1 over 2 is equal to 6. So since I don't want to retain this power again, what I will do is I will introduce to this power its reciprocal, or what we can call the inverse of this power. Now if I have 1 over 2 for instance, its reciprocal or its inverse is 2 over 1. That is when I reverse this number by allowing 2 to go up and 1 to move down. So the result that gives is what we call the inverse of what? Of 1 over 2, or reciprocal of 1 over 2. Also, if I have 5 for instance, if I'm interested in its reciprocal, the first thing I will do is to ensure 5 is what? A fractional number. To introduce its reciprocal to it simply means I will multiply it by what? Writing this number in reverse form. That is, by allowing 1 to come up and 5 goes down. So that is what I will do here in order to unravel this, my what? My power. So that's going to be multiplied by 2 over 1. And remember, we call it indicial equation. It means we are solving the equation. And the equation is a system of balancing whereby what happens in one side must happen in the other side. That is, what happens in the left hand side of this equation must also happen in the right hand side of the equation. And what actually happened in the left hand side is that 2 over 1, or what we can simply call 2, was introduced to this x. So definitely that 2 will also be introduced to the number which we have at what? At the right hand side, in order for us to be just in our dealing. So we can say 1 cancel 1, 2 cancel 2. X is no longer with such a power, so which now becomes 6 raised to power 2. So x here is now going to be what? 6 times 6, which finally gives the value of what? Of 36. So that is question 5. In number 6, in question number 6, there we are asked to simplify or to solve 2x raised to power minus half is equal to 5. That is the question there. So solving this one is also very simple. The way to deal with it is this. We can see that when we talk of index number, we expect it, what we call the base, not to have a coefficient. So that whenever we are relating with equation, so our base, we expect it not to have what? Not to have a coefficient. So whenever it has a coefficient, such a coefficient has to be removed. So, and the best possible, the possible way by which this coefficient, that is 2, can be removed here is to what? To divide both sides by such a coefficient. So both sides, first of all, has to be divided by what? By 2. So when we divide by 2, the result this gives now is x raised to the power minus half is equal to 5 over 2. Now, in order to progress with this thing, simply means we want this x to exist without having any power again. And one of the best way that can be achieved is by what? Introducing to this power its reciprocal, that is its inverse. Or when we write this power in opposite form and multiply it by this number, that is what will enable us to get rid of what? Of entire power here. So to do that, I will have to rewrite this level. So x raised to the power minus half multiplied by minus 2 over 1. Here becomes 5 over 2 here raised to the power minus 2 over 1. So if you are following, you can see that what happened here was that minus 2 over 1 was introduced to x raised to the power minus half. So similar thing must also be introduced to what I have in the other side of the equation. So in that wise, 1 cancel 1, 2 cancel 2. So no minus times minus there becomes plus. So that now becomes x is equal to 5 over 2 raised to the power minus 2. One of the basic principles or one of the basic law in indices is that our base is not allowed, as far as indices is concerned, to have what? A negative power. So when such happen, what we are going to do is to remove the negative sign. And the way to remove the negative sign is, first of all, to ensure that our base occur as what? As a fractional number. Now, as a fractional number, a mere interchanging of the position of numerator as well as denominator is what eliminates or what makes this negative sign to disappear. And that's what we are going to do now. 2 moves up, 5 comes down, everything here raised to power 2. So we can see that once the two numbers, that is my numerator and denominator, changes their position, the minus sign will automatically disappear. And what I have here now means I should write 2 over 5 2 times. That's the meaning of 2 over 5 raised to power 2. So x in this case gives 2 times 2 here is 4. 5 times 5 here is what? 25. So, and the result. So solving our 6th question gives the value of what? The value of 4 over 25. Now the next question is number 7. And in number 7, what I have is this. Number 7, I will have to write it so that I won't have to make reference to this initial paper here. I have 2x raised to the power minus half is equal to minus 14. And by my number 8, I have 5x is equal to 40x raised to the power minus half. So I'll be able to solve without moving up and down now. Now, solving this thing means, okay, now let me write my question 7. 2x raised to the power minus half is equal to minus 14. Just like we did in the previous question, that is in question 6. This our base, that is the one that has the power of minus half. We want it not to exist without any coefficient. So since it has a coefficient, such a coefficient is the first thing we have to remove. So we first of all divide both sides here by what? We divide both sides here by 2. So when both sides is divided by 2, the result that gives is this. 2 break 2 here. I'll be left with x raised to the power minus half is equal to minus 7. And the next thing in the solution is to ensure that this x exists without having any power, and the only way that can be achieved is by making sure that what we introduce the opposite or the inverse or reciprocal of this minus half to minus half. So doing that is this: x raised to the power minus half multiplied by minus 2 over 1 is equal to minus 7 raised to the power minus 2 over 1. Now the reason being that what happened in the left hand side of the equation must also happen in the right hand side of the equation. So we see one minus cancel minus, one cancel 1, 2 cancel 2. We'll be left with x is equal to minus 7 raised to the power minus 2. And from our previous classes, we know very well that our base must not have a negative power. So what we do in that case is to remove the negative sign. So removing the negative sign here means base first of all must occur as what? A fractional number. So x here becomes minus 7 over 1 everything raised to the power minus 2. So to automatically remove my negative sign now means 1 will move up, minus can be at the middle, and 7 move down like this. So minus now disappears. So we are now left with minus 1 over 7 squared, and that means we should write minus 1 over 7 twice. Minus 1 over 7 times minus 1 over 7. So s automatically give minus times minus there is plus. 1 times 1 1, 7 times 7 49. So result to solving our question 7 is what? 1 over 49. And finally today in our class is to solve question 8. And what we have there is 5x is 40x raised to the power minus half. So let me rewrite my question. 5x is 40x raised to the power minus half. Now, when we observe the question, especially the one we solved last year, so we can see that this thing also has a pattern. So a student, it's very important the student understand the patterning of the question he or she is solving. So the patterning in this situation is that in one side of the equation, letter or variable usually stays there, while in the other part of the equation this is purely number we are going to have there. Now that we have both mixture of number and letter here, so that separation has to be done. So what to do here is this x here, it might be that I want it to come here, or this x raised to the power minus half is the one I want to come here. So it depends on the person, the nature or the type of person solving the question. But the approach I want to use is the one having raised to the power minus half is what I want to move from here down to this place. So what I will now do in that wise is I will divide both sides. Since I don't want it to be here, the complete x raised to the power minus 5, I don't want it to be there, I will completely remove it. And the way to remove it is to divide both sides by it. So I will have it as x raised to the power minus half, this one over x raised to the power minus half. So this one cancel this. What we have now is this. We can rewrite it as 5x divided by x raised to the power minus half is equal to 40. And by basic law, we can as well call this raised to the power 1. That becomes 5x. Remember, when base are the same thing and division is the sign, what can happen is what? Division changes to minus 1 minus the number we should add the half is equal to what? 40. Now to continue, this thing means we are going to rewrite it as 1. Now we can see when sign follows sign, it's a call that what? We should multiply the two signs. So minus times minus here gives plus 1 over 2 is equal to 40. So that gives 5x raised to power 3 over 2, because we know the result of adding 1 to 1 over 2. That can be done here. 1 plus 1 over 2 is the same thing as 1 over 1 plus 1 over 2. LCM here is 2. 1 into 2 is 2. 2 times 1, 2 plus 2 into 2 is 1. 1 times 1, 1. 2 plus 1, that gives 3 over 2. So that is where the 3 over 2 here is gotten, which is equal to what? 40. Now we can see that we've been able to adjust it to a question of this form that more or less look like this one. Now what follows now is we want only our index number, only our base of x to be here. We do want it to exist without having a coefficient, so the coefficient has to be removed. So removing the coefficient here means I will divide both sides by 5. So 5 cancel 5 here, So I now have x raised to power 3 over 2 is equal to 40 divided by 5 gives what? 8. Now what happens now is we want to remove the power in order to be able to arrive at the value of x. Doing that means I will introduce to this power its opposite, its inverse, or what we can call it its coefficient. So that becomes x raised to power 3 over 2 times 2 over 3 is equal to 8 raised to power 2 over 3. So 3 breaks 3, 2 cancel 2. So x now is equal to 8 raised to power 2 over 3. We can see this one has landed us into another good property in indices, which simply means this is a case of fractional index. So in that wise, whenever our power is a fraction, it simply means we should take certain root of 8. So since we need root of 8, so that's going to be root 8. What root? So the numerator here becomes the power, while the denominator here is the element of the root. So x here is now going to be, now we need to interpret in order to arrive at our x. So it means we are looking for a number that when the number is repeated 3 times, result it gives it, and we know the number that will produce such a result is 2. So that becomes 2 raised to power 2. And x here simply means we should repeat 2 times. That is, we should write it as 2 times 2. And finally, x gives the value of what? 4. So, and that is everything which we want to learn for under the laws of indices as far as the SS1 class is concerned. So I hope to meet you once again. So when we shall be discussing another interesting topic. So I say thank you very well for joining this class, and remember to subscribe to this channel by viewing, by liking, as well as by sharing it. Thanks for joining the class once again. Bye bye.